Here we are at the Nelson Hydro Generating Plant, proper name Bonington Falls Plant, here in Blewett, established in 1896, the city of Nelson. Kevin Johnson is kindly going to give us a nice tour.
Welcome everybody to the City of Nelson's Bonington Falls Generating Station. My name's Kevin Johnson. I'm a millwright as a tradesperson for Nelson Hydro. So this plant has been here running since 1907, and as of today it is still running, and we're running 2 units here. We have 4 that are available, but typically we only run 2 of the 4. So let's go for a walk and we'll show you the works. So this area here, this body of water here, is called the forebay. So this is basically just the pool of water that then gets distributed to whatever units are running. And like I say, today we're running two units. So there is a dam that raises this water in the upstream area about 20 feet from what it was originally. And on the opposite shore, we have another generating station that is run by FortisBC. It's much larger than ours, but the same in principle. And then up around the corner upstream is the Coralin Dam, which is the first dam on the Kootenay River on the Canadian side. So right in front of us here are cable trays. This takes the electricity, the power from the generators up to a substation that's just up over the hill here. So these cables here at 12,000 volts, they're insulated cables, so they're safe within that tray, but that is just a better way of doing it rather than having overhead lines, which are more troublesome near waterways, especially with birds and whatever.
I noticed that down there you have some grates in front of your openings.
Yeah, so those are called trash racks. So those keep the larger wood debris from getting into the turbines, into the units. So typically once a year we'll clean all this wood debris out. So we're kind of due for it now. It's getting a little bit filled up.
Find anything interesting in there ever?
Not often.
No canoes?
No canoes.
I guess they've already gone through a dam, so they've already had to go through one.
Yeah.
Awesome.
So this gate right beside us here is another gate that's used for maintenance. So say if we're to clean out all this wood debris, we'll pick a day in the summer when we're not needed to produce so much power. We'll just buy more from Fortis, and we can lower this gate and stop the flow of water. The units have been shut down just prior to that, and then that makes that drain, and that's about 7 meters deep, and then we can more easily clean out all the wood debris. So we'll go for a walk further down below. Okay, we're still at the forebay here. So each one of the generator units has a gate, basically for maintenance. So starting over here, there's a silver gate. That's our oldest unit that hasn't actually ran since the 1970s, but next to it are 2 older units, there's 2 green gates. And then the third guy there is a silver gate that was installed in 1950. And then over to the left here is another gate, which is actually hydraulically operated. That's for unit 5 that was installed in 1995. So those gates, like I say, are basically for maintenance. So if you want to get in and work on the turbine, the unit's shut down, the gate is lowered, and then the water will drain out from the penstock and turbine. So that's a pretty good view of the FortisBC plant over there. We're at Upper Bonington Falls here at this site.
And you feed your power to Fortis, that's correct?
Yes, basically, yeah. We buy about 50% of our energy from Fortis.
The city of Nelson?
Yes,
right.
Over the period of a year.
Right. So our generating plant that we're going to take a tour of today has enough power to power how much of Nelson?
Well, typically half.
Half, okay.
Half, which includes the outer areas like the utility and encompasses more than just within the city limits.
Right.
All the way out to Coffee Creek, out through Blewett on this side, you know, to Tagum proper. So there's a lot of, the outlying areas use as much energy as within the city limits.
Right, gotcha.
Yeah.
Perfect.
Well, we'll head on down to the powerhouse. Okay, we're down just outside of the powerhouse. So this large pipe here is what we call a penstock. So it takes the water from the forebay through this pipe. This is for Unit 3. And this pipe is about 6 feet in diameter, and then it goes down at this point about another 20 feet to where the turbine is in the lowest level of the powerhouse. So again, at the top of this penstock is a gate, which we call a head gate. So that's basically the service gate for this one penstock for this Unit 3. So up here on the wall is basically what we call an elevation view of this powerhouse. So this is a Unit 3, so that was the pipe we were just looking at, the supplies for this turbine. So these represent the turbines, all on the lower end, and up on the top here is all the generators. So we have 4 units here. This oldest unit is not running, hasn't ran since the 1970s, so these 2 units, 2 and 3, are standby, and today we're running our Unit 4, which is the normal running unit. We run units 2 and 3 if we want to take down one of the other units for maintenance or having troubles.
You can see the red cables heading above us here. Those are the 12,000 volt lines from the generator up to the substation above the plant.
Good unit to show people because we can safely go hands-on without being at risk of getting electrocuted or something. So right inside here are the actual coils. So these are called the stator coils. So that's what would generate the power when this unit was running. So these coils would normally be at 12,000 volts if the unit was running. And this part inside of it here is called the rotor. So this is the part that would be spinning by force of the water when it was running. So then on the outer edge of the rotor are these poles which have DC power running through them, and they're what create the large magnetic force to create the power in the non-moving stator coils here.
So your magnets are spinning, not the wire.
Right.
Exciter.
Yeah. So off to the side here, we'll go to our Unit 2. So this is a hydraulic governor, so it's oil under pressure, about 200 psi. So it operates a hydraulic cylinder, which is here, and by operating that hydraulic cylinder, takes that movement force down to the turbine floor to operate what we call wicket gates. So wicket gates are like shutter doors that work simultaneously that surround the turbine, and that's what can stop the flow of water or start the flow of water to operate the unit. So right now this unit's stopped, so this servo is in the fully closed position, so that has the flow of water stopped in this unit. So once it would be started, we can manually operate and get the unit spinning and get it synchronized, what we call, to get the unit online to produce power. years ago, they put electric motor to drive it. Switchgear. So each generator has its own circuit breaker. So right here it's unit 3, unit 2, unit 4, and then we have a main circuit breaker. So these circuit breakers are basically just a big electrical switch to separate the generator from the line or the load. So these breakers inside of here are at 12,000 volts. And then the main is a kind of redundancy backup breaker that if there's a major fault here, the main opens to clear the fault behind. So that in behind all this, there's insulated copper conductor inside a real scoop of insulation for 12,000 volts. So then right behind us here is what we call our static exciter. So unlike that oldest unit, 1 and 2 have a rotary exciter, these are actually just a large transformer that takes the 12,000 volts, the power that comes out of the generator, just a portion of it, small portion of it, goes through a rectifier and creates DC power out of the AC power that comes out of the generator. So that power is then fed back into the rotor of each unit. So right here is our unit 3 exciter, and then this is our unit 4 exciter. So it's just a little bit different process of doing the same thing. One thing that's easier on this setup here is you don't have carbon brushes rotating on a commutator. It creates a lot of dust, a lot of wear. This is hence the term static. There's nothing really moving here physically. It's all done with diodes and electronic equipment.
What would you use before the generator is up and moving to excite it? Or is it that you just get the water spinning the turbine and spinning the generator?
Right.
I see. Okay. Gotcha. So before it's put online, you just open up the gates, you get the water spinning through the turbine, generator. Okay, I gotcha.
Yeah.
And what's behind you?
What's behind me is what we call a synchro-scope. So to put a unit online, we have to match the AC sine wave to that of the grid. So this is the running AC volt, so that's the voltage times 1,000 for the grid. So typically, like I say, we're going to close in, it's going to be just over 12,000 volts. So that's running, that's the system. Incoming is whatever generator we've selected to put online. So these voltmeters have to match, so it's adjusting the excitation voltage on the unit that's incoming to match the running, match the grid, and then that's the frequency. So that frequency is basically telling you the speed of the unit. So the speed of the unit, when it's correct, will give you that 60 hertz, which is the 12 o'clock position. And the synchro-scope, the top guy, is actually telling you the frequency, but whether the unit's going too fast or too slow. It's just confirmation of the frequency in a sense. And the two light bulbs are telling you again the voltage difference between the grid, the load, and the unit. So when the light bulbs go out, that is the actual signal of when it's safe to close in the breaker.
Oh, very cool.
So this unit was installed and running in 1929. So it's fed by that water pipe, the penstock that we looked at first outside the building. So right beside it here is its governor to operate the wicket gates. this gives us the actual physical run out of the shaft. So these two look at the upper part of the shaft of the generator, and these two look at the shaft at the turbine. So depending what's going on, like if these ones read high, this will actually shut the unit down if it gets a high enough reading. And again, it tells us to do a bearing adjustment, or if there's other issues around that. But it's just a physical monitoring. Something come loose in the rotor generator, that's another fail-safe kind of check for the unit to make sure it doesn't incur a lot of damage.
Are these numbers attached to the sensors that we see that are right near the shaft?
Right.
Okay, so I'll point those out in a bit.
Yeah.
Okay.
Yeah.
Here we are looking down at Unit 4. So that is number 4 generator. Walking down the stairs, it is currently running, so it's a little bit noisier down here. Here's the governor, off to our left, beside it the generator, and in the center the shaft running the turbine. We are now walking down to the turbine floor. There is the shaft spinning. Below us will be the water that is turning the turbine, and above us is the generator. You can see here and below are the linkages for the wicket gates that are controlling the amount of flow through the blades. There is the governor that actually controls those wicket gates.
This is our unit G2, so we're again still on the turbine floor, and this is the turbine for our unit. Its scroll case that is actually made of castings. It's similar but different. The newer units use a lot less metal. This unit being 1910, it has quite thick castings. So in the later years, they learned how to make it out of plate, which used a lot less metal, but it's all still similar. So inside this is the water, again under pressure from up the forebay, and again this unit is not running. This is a standby unit, so it's just sitting here stopped. So off to the side again is the governor shaft, connecting it to the linkage. The linkage on this unit, all the linkage is inside, actually in water. It's a little bit more difficult to maintain, but it still works pretty good for a unit made in 1910.
Above the bearing, we can see a vibration sensor, which was what we were looking in the digital readout on the annunciator panel. Above, along the shaft, is another bearing, and above is the generator.
So this is a spare. We're down on the turbine floor, so there could have been another turbine put down on this floor with the generator on top, but it never occurred. So we'll go in and look around the corner. You can see where the pin stock comes down, and it's just open. It's capped off at the top, but it's void of all the equipment that would normally be in a cell to have a hydro generating unit there. So this is our unit 5. So this unit was built in 1995 or just prior to. So this unit, the main difference inside here is it's a horizontal unit. So all our other units that we just looked at have vertical shaft, vertical turbine generator. This guy is laid down, and this guy's turbine is called a Kaplan. It looks like a large boat propeller. It's about just over 6 feet in diameter and it has 5 blades. And those blades all work in unison, and they change their pitch. So if the unit's at a low loading, low power output, the blades go further flat, and then at a higher output they go open, so it stays much more efficient. The other units are called Francis turbines, so they're designed for one fixed, basically water flow, so you can't run them at a low power output as this unit can. So this unit has a lot more options for what loading you can use it at.
We are about to walk underneath the turbine. You can see the wicket gate linkages there, and attached to them is a scale that shows us how open they are. If we look closely, we can see that the gates are open 75% right now. We are looking at the hydraulically actuated governor that controls the wicket gates from being completely open to being completely closed. And here is a standard operating procedure for changing out the oil system filter. Ahead of us here is the spinning shaft rotating from the water going and flowing through the turbine. We can see a water seal to our far left, a friction bearing in its white housing ahead of us, and another friction bearing in the gray housing straight ahead of us here. The large square box is the generator, which, as Kevin has mentioned, generates 12,000 volts phase to phase. Not very easy to see within the generator, but no different than generators 1, 2, 3, and 4. We have rotating magnets and stationary wires. Another friction bearing right ahead, and in the very background, we'll be able to see the wires leaving the building. There is the red tech cable going up the wall and eventually out the building. We are now on the middle floor in Unit 5's building. This is our control center, showing us all of our various gauges for AC and DC amperage, voltage, as well as frequency. So here we can see that we are getting about 118.98 volts phase to phase at approximately 60 hertz. Shows us our speed of the turbine, the gate positions, and the blade positions. And then we have a digital control panel as well, and lots of other buttons. Here's our MCC unit to be able to lock out all of the pieces of equipment for Unit 5.
Outputs for generators 1, 2, 3, and 4 out of the main generator building, turbine building. And here is Unit 5. Here we are at the substation that the plant brings up their power to. They step it up and they head onto the transmission lines into Blewett and then further on into Nelson.
Around the plant, there are many photos of the different turbines being installed back in the day. I love this tour because all of the generators are nice and open and you can actually see what's going on. The newer generating plants, everything is covered and nothing is easily seen. Some beautiful heritage equipment, keeps working, it'll go forever and ever. Beautiful views, it's so quiet, I love going there. Thank you so much, Nelson Hydro, for such a wonderful tour and giving us this great opportunity.